Yeah, in this session, we are going to see about an operation of stack. Once again, the stack is one of the types of linear data structures. Already in linear data structures, we have seen about an arrays and linked list. The stack is then another type of a data structure that is called linear data structures, where we will store the data one by one. Then here the stack. Where do you use a stack? Generally, what's application of stack in day-to-day life? So, for example, in our kitchen, we will stack the plates one by one. We will stack the books in library one by one after another, one after another, one after another. So, whichever the books come at last, okay, that's the books will be taken outside. For example, if you arrange the books after one by one, another after one another, then the last books we have kept that will be taken first outside. So it will work on the operation of last in, first out. Last in first out operation. So generally in the application of stack is in normal MS Word we will use always Control Z. Okay, undo and redo. So there what happens over here? There application of stack is happening. When whichever is deleting, we are deleting, it will go and store in the stack. Then by doing undo, it will pop the elements from the stack and give it back in the display. Okay, that is a basic application of stack. And then for recursion calls, for what's a recursion calls? For example, I am teaching you people. Then in between, and one person has come and asked me the some doubts. So now what I will do, I will hold on the topic which I am teaching for a moment, and then I'll go and do the service for the, and then I'll go and clear the doubt for the other person, and then I'll come back and resume where I have left. So for resume, how do I know where I have left? So I'll store in the stack, and then I'll go and do some function calls, and then I'll come back and I'll take from pop from the stack. I'll resume the work. So this is the application of stacks. So now here in today's session, we will implement the stack using an array. We will implementation of stack using an array. So at first, whenever we do program for a stack, we should define the stack size. Okay, so we will define the stack size, define and n as 100. So this is the maximum size of a stack. So now once you define the size of a stack, then we will use an corresponding declaration of a stack in an array. So integer is a data type and stack is the corresponding keyword, the corresponding the variable name we are giving for the stack, and then of n, where n is the size 100. So in stack, if I observe, there are many operations are there. The first operation is called push and pop and peek, and then is full or is empty. Push means it will insert a data into the stack. Pop means it will remove the data from the stack. Peek means it will show the top element in the stack. And then is empty will check for the stack is empty or not. Is full, it will check for the stack is full or not. So these are the operations which will be having in the stack. So now once you define the stack as an array, so then always here we have a keyword is called top. Okay, the top is in the stack. The top will always points to the top element in the stack. The top element in the stack. So, for example, so this is the stack I have taken. So here there is no data. There is no data. So if there is no data, that means that top is equal to -1. top is equal to minus 1. Okay, so the index value for this is 0, 1, 2, 3, 4, and 5. So these are the index values. These are the index values. Okay, not a data. These are the index values. I will add one more column itself. So for the better understanding. Here we will store all the data. So now you tell me, is there any data in the stack? No, right? So the top will be equal to minus 1. So initially, the top will be equal to minus 1. So the initial condition is top is minus 1. So I have mentioned as top is minus 1. So then we will do the operation of push. Since there is no data in the stack, we need to insert a data in the stack. So for that, we need to perform operation called push. So here we are going to perform push operation. So in the push operation, at first we need to have an variable, okay, because that's a data. For data need to be stored in some variable. So I'm going to declare the variable as an x as an integer, x as an integer. So then once you declare the variable, then I can ask the user to enter the data, and then I can scan the data in the x variable. So here I have asked the user to enter the data, and then it has been scanned through x variable. So once you scanned through x variable, so then what happens over here? Before uh, entering a data into the stack, I will check whether there is a full amount of data is there or not in the stack. Generally, for example, in a class, I can store maximum of 60 number of students. If 61st person comes into the class, then I will say that no, class is already full. You cannot come inside. Okay. Suppose, for example, if there are 50 students are available in the class, still there are 10 more vacancies are there. Then I will say that okay, you can come inside the class, and then you can come and sit in the class. So what I'm going to do here, at first I will check the uh, memory space is available or not for the input data. Okay, so for the purpose, what do I do it over here? So for example, here in our stack, the stack size is 0. So 1, 2, 3, 4, 5, 6. There are 6 amount of data can be stored. Okay, so let me say define n as a 6 itself. Define n as a 6 itself. So now what happens over here? So 6 is the maximum data. So 6 means what? The index is starting from the 0. Index is starting from the 0. So if top is equal to 5, if top is equal to 5, then that indicates that data is already full in the stack. For example, I am storing the data called 6, 4, 3, and 8, and 9, and then there is something called a 10. So now if you observe over here, in all the memory elements, in all the memories, we have stored a data. So stack is completely full. So as you, as the data has been full, so the top will be pointing towards 5. Top is pointing towards a 5. So there are 6 number of data can be stored. Top is equal to 5. That means that if top is equal to n minus 1, then that is called overflow. If top is equal to n minus 1. So I can store maximum of 6 number of data. So in the 6 number of data, all the 6 number of data has been entered. So it is showing top is equal to 5. What's the purpose of top? Top will always point towards the top of the element in the stack. So here the top of the stack is 10. So 10 is a data. So top is pointing towards the fifth index. So that is what n minus 1. So if top is equal to n minus 1, then the stack is overflow. So now here, at first, once you enter the data, once you get the data from the user, you cannot enter the data into the stack immediately. At first, you should check the memory space is available or not. Once memory space is available, then you can store the data. So for that, you should check the condition if top is equal to n minus 1 or not. So here I will include a condition called if top is equal to n minus 1, then I will print it as a overflow. So here what I've done over here, if top is equal to an n minus 1, then I'll print it as a overflow. So this case is, we have seen it through the example here. Top is equal to n minus 1. Top is equal to 5. So n minus 1 is, what's n? N is the number of data 6. N is the 6. So 6 minus 1 is 5. So that means top is equal to 5, that's a overflow. We cannot enter the data, more data into the stack. So now let us take, suppose if there are 3 data are only available. So now top is pointing towards a index called 1. Top is pointing towards index called 1. So now we will go for else condition. In the else condition, so in the same case, if top is equal to n minus 1, what's the n? 6. 6 minus 1, 5. So but here in our case, in the second case, top is equal to 1. So top is equal not is equal to 5. So top is 1. So this condition gets failed. This condition gets failed to go for the else condition. That means that the memory spaces are available in the stack. We can store a data into the stack. That's the meaning. So now we'll go for else condition. So at first, whenever we go insert a data in the stack, at first we should allocate a memory space for a data, and then we will put a data into the stack. So now what do I do it over here? At first, I'll allocate a memory space for the data. So top will be increments to the top is equal to 2. I have allocated memory space. So now once the memory space has been allocated, then I can enter a data over here. So 9 is a data. 9 is a data. So at first I have allocated memory space. That means the top is equal to 2. Top becomes 2, and then I want to enter the data as a 9 into the place. So at first in else condition, at first we will increment the top by 1. At first we'll increment the top by 1. So top becomes 2, and then in the stack of top I will store the data. So what is stack of top? Stack of top is nothing but on it, stack of top is equal to x. So what's the top? Once you increment the top becomes 2. In the stack of 2 I will store the data called 9. So we have stored the data called 9. So this is the operation of push in the stack. So next one we will see about pop. So in the push operation, nothing but a simple one. At first, we have got data from the user, and then I have checked whether the memory space available or not. If memory space is not available, that indicates overflow. If memory space is available, I have allocated memory space for the data, and then I have stored the data into the stack. Push the data into the stack. So this is operation called push. So now we'll go and perform pop. What's a pop? Pop is nothing but removing of data from the stack. Removing the data from the stack. So for removing the data from the stack, what we do once again, at first, here are the cases. At first, I will check whether data is available or not. If there is no data available in the stack, then we cannot remove any data in the stack, right? So it's called underflow. If there is no data available in the stack, then that is called underflow. No data in the stack. That is called underflow. What's overflow? If there is a full amount of data, okay, all the sizes of the whole stack size has been completely occupied. That is called overflow. If there is no data available in the stack, that is called underflow. So this is operation. So at first, while I'm doing pop operation, at first I'll check if top is -1, then I cannot remove any data, right? So it is an underflow. It is an underflow. So then what do we do over here? So if top is equal to not equal to n minus top is not equal to -1, then that indicates that data is available in the stack. If top is not equal to -1, then that's meaning that there is data available in the stack. So if top is equal to -1, it is called underflow. If top is not equal to -1, then that indicates that data in the stack. Data in the stack. So now these are the conditions. So by having these conditions in the mind, you will write a coding for the pop operation. So as usual, we will declare the function called an pop item. I have declared the int item, or I will tell the reason what's the purpose of an item and in the upcoming lines. So then at first what do we do? I will check for the top is equal to -1 or not. If top is -1, that is an underflow, right? As simple as that. So if top is equal to -1, I will print as a underflow. I will print it as a underflow. Else, what I do over here, I will take the top data from the stack and then I will store it in the variable called item. Okay, so now here in our case, the top is 2. Okay, so stack of top is nothing but the index, stack of 2. Stack of 2 stores data called 9. So that 9 will be stored in a variable called an item. So item is equal to stack of top. Okay, and then we have decrements the top because this data has been removed. This data has been assigned to the item. So data has been removed. So the top will be gets decremented. Top will be gets decremented. It will be equal to 1. Top is equal to 1 because the data top available data over here is 4. Okay, the above data has been moved to the item variable called item. So item is equal to stack of top, and then I have decremented the top. So top becomes 1 in our case. So when top is equal to 1, then I'll print the element which we have popped from the stack. The popped item is equal stack of top, right? So here we have taken the first data as a 9. The 9 will be printed as in the popped element in the stack. So this is operation called pop. This is operation called pop. So simple in pop, at first I have checked if top is equal to -1 or not. If top is equal to -1, it's an underflow. Else, I have taken a data at top of the stack data and stored in a variable called item, and then I decrement the top by 1 position because we need to remove the data from the stack. So when we remove means what? Always we will remove the top element from the stack. So we decrement the top. Once we decrement the top, then we have printed the popped item as a data, which data we have removed. The data has been printed in the output side. So this is operation called pop. So then once push and pop is completed, then we'll go for peek. So peek. So here the peek will always gives the top element in the stack. The peek will always give the top element in the stack. So now, if there is no data in the stack, then stack is empty. It's underflow condition. The stack is empty. So for peek operation, at first, if top is equal to -1, if top is equal to -1, then the stack is empty. So at that time, you cannot give the corresponding top element. That time it cannot give the corresponding top element. So now here, if you observe over here, void peak and top is equal to -1 and stack is empty over here. So now here, if you observe, the peak is always gives the top element in the stack. So if top is -1, then that means that stack is empty. Stack is empty. So if top is not equal to -1, if top is equal, in our case, what happens over here? Now top is equal to 1, right? So the peak will shows the top value. What's top value over here? The data is 4. The 4 will be printed in the output side. So now here for that else, I will print the top element. I'll print the top element in the output side. Simple. So print of top element. So stack of top. So in the stack of top means what? Stack of top is now top is equal to 1. Stack of 1. So stack of 1 is 4. The 4 will be printed in the output side. This is the operation called peak. So peak means what happens over here? At first I'll check for top is -1 or not. If top is -1, stack is empty. Else I'll print the top element in the stack. This is the operation called peak. So now, for example, if I want to display all the data in the stack, if I want to display all the data in the stack, so simple as that. Once again, for display operation, at first I will check if top is -1, the stack is empty. Else, I'll put a for loop. Okay, in the for loop, I'll go one by one. Okay, stack of 0, stack of 1, stack of 2, stack of 3. Okay, so I'll be keep on decrementing. So I'll start from top element. I'll decrements. So top is equal to 1, top is equal to 1. I'll decrements. Then top of stack of 0. So until it becomes 0, it will be keep on printing all the elements. That is the operation called an and display. Display means what? It will display all the elements in the stack. So now here, what happens over here? I have declared variable called I. At first, I'll check for if stack is empty or not. So I have checked by using condition called top is equal to -1. If top is equal to -1, stack is empty. Else the stack elements are, I have used for loop over here. So for I is equal to top. In our case, what's the top value? So top is 1. Top is equal to 1. So now here I is equal to 1. So in I is equal to 1, and then it should be greater than or equal to 0, because until index 0 it will be keep on going. So stack of 1 will be gets printed, and then I decrements. So 1 becomes 0, then stack of 0 gets 0, stack of 0 gets printed. So then this for loop gets fails, and then it comes out of the loop. So it will display all the data in the stack. So in this session, we have covered what's the purpose of stack, what's the application of stack, and then we have seen the operation called and push, pop, peek, and display. Push means insertion of element in a stack. So to check for overflow or not. If it's overflow, it will not enter the data into the stack. And if it's not overflow, it will enter the data into the stack. And then pop, remove the data from the stack. So underflow, at first I have to check for that and it's an underflow or not. So if it's underflow, you cannot remove the data. If it's not underflow, then I'll remove the top element from the stack. Then peek. Peek means what? It will shows the top element in the stack. And then display, which displays all the data in the stack. So this is the operation of stack, implementation of stack using an array. Thank you.